Assalamualaikum. My name is Zamry bin Zakaria. Matric number B0819100318. In this video, I will explain about Lab 8 Microcontroller simulation using Proteus 7 Professional or subject in workshop. In this lab, we have 4 questions, part by part, and I will explain about part A first, basic input-output circuit. So the instruction is design and construct Arduino Uno, develop board circuit diagram using Proteus Professional software. I already done my circuit, develop my circuit, build my circuit, and how to build the circuit already explained on previous video. So I will go to instruction number 2. So using Arduino IDE, compile example program button .ino. So we go to Arduino IDE and go to file, example, go to digital, and we select button. This is the source code for the button, and we can just upload. This example is nothing wrong. Okay, after we upload, we go to instruction number 3, load hex code into the microcontroller. So we can find hex code in the error message. Copy all C directory. Okay, Ctrl C for copy, and we go to Proteus software, double click to microcontroller, and paste the directory in program file. Ctrl V for paste, click OK, and then we go to instruction number 4, run the simulation. Okay, here we run the simulation, and the last instruction is push button to turn on LED. So this is the LED. I will zoom. Okay, push button to on the LED. This LED color red. So we push the button, and LED will blinking. Okay, LED on. Push button on. LED is on, and push button. We release the push button. LED is off. Okay, that is for the part A question. Okay, we go to part B. Part B is tone melody, and the instruction is design and construct Arduino Uno. Already done the construct the circuit. And second instruction, using Arduino IDE, compile example program tone melody Uno. So I go to Arduino IDE, go to file, example, digital, go to tone melody. Okay, this is the source code, and we just upload. The error message is serial port not connect selected is because our Arduino is not connected to any device. So we go to instruction number 3, load hex code into the microcontroller. So we go to Arduino IDE, find the hex file. This one is file from the C drive. Copy, load Xcode into the microcontroller. So double click to the microcontroller and we replace the program file. Okay, click OK. Okay, instruction number 4, run the simulation. Okay, we run the simulation. And we hear sound from speaker. Okay, that is for part B. And we go to part C, controlling motor. Part C is controlling motor, and the instruction number 1, design and construct prototype microcontroller circuit. Same as part A and part B. I already construct my circuit, and we have one variable resistor, motor, and 3 LED and controlling motor. And when we go to instruction number 2, using Arduino IDE, write a program. Red LED will on when the potentiometer or variable resistor is 0%. And after that, yellow LED will on after reach 50%, and green LED will on after potentiometer or variable resistor reach 100%, and at the same time will turn on the motor. At the same time, all 3 LED will on. I already write the program. Okay, for the program, we declare all the pin mode, and for analog rate A0 less than 10, and LED red we hide, that's mean on. LED yellow and green low, this mean off. After A0 reach 500, this mean 50%. LED red will hide or on, LED white yellow on, and LED green is low, this mean off. So 2 LED on and 1 LED off. And after A0 reach more than 550, this means 100%. LED red hide, LED yellow hide, LED green hide. So all the LED hide, this means all the 3 LED is on, and the same time pin 1 for motor will hide, this means on. Okay, we run the program. Okay, serial port not selected, don't worry, because this Arduino IDE not connected to any device. So we find the exa file, hex file, on C, copy all, Ctrl C for copy, go to Proteus, double click to the microcontroller and paste the link in the program file. Then we set the variable resistor to 0%. Okay, to gain and to decrease. Okay, we run the simulation. On 0%, LED red will on, is high on, and we change the variable resistor to 50%. Okay, we can see when they reach 50%, LED yellow will on. red and yellow on, and we gain the value to 100%. At the time you can see the three of LED we on. Okay, 3 of LED we on, and the motor will running, and we drop the percentage, and we gain the percentage at the same time, 100%. When 3 LED is on and the motor will run. Okay, this is for part C. The last part for this lab is part D, LCD display, and the instruction number 1, design and construct prototype microcontroller circuit diagram using Proteus. So this is the circuit diagram, and I already done my circuit. Instruction number 2, instruction number 3, we must add temperature sensor LM335. So go to circuit, pick the component, and type LM35. Okay, this is the LM35. We add LM35 here. Okay, and put inside the circuit, this one. Okay, instruction number 4, using Arduino IDE, modify and the given program and load into Proteus professional. Okay, this is the program. We copy all the program and open Arduino IDE. Okay, Control all, this means select all, Control A, and paste, Control V. Okay, not copy yet. This is the file, copy and paste into the blank Arduino IDE cache. Okay, and then we save. Okay, we rename for part D. After finish, we verify first to compose cache. So done compiling, nothing error, and we upload to program. Okay, same as before, there is no port selected because we not connect our Arduino IDE to any devices. Okay, now we select, we copy all the hex file directory, we copy, Control C, go to Proteus, same as part A, B, and C, double click the microcontroller, and we paste the directory inside the program file. Control P for paste, click OK, and then we running the simulation. Before you running the simulation, we go to question. Meter must have a value for 10%. This means our value here, we drop it until 10%. Okay, 10%, and we can see the display from the LCD display. The real voltage inside the LCD display. So we run the simulation. Okay, for 10% meter temperature, the voltage is 0 because our program here we just copy and paste the sensor value. Okay, just direct variable, we're not using float. This means the LCD cannot display decimal point value. So in 10% is 0 volt. Okay, in 10% is 0 volt, and we gain to 20%. Okay, we gain to 20% is 1 volt. 20% is 1 volt. We gain to 30% is still, okay, 30% is 2 volt. 30% is 2 volt, and we gain to 40%. Okay, the value is 2 volt. 2 volt. We gain to 60%. The value is 4 volt. Yes, 60%, the value is 4 volt. 80%, the value is 5 volt. 80% value is 5 volt, and 100%, the value is 7 volt. 100% value is 7 volt. Okay, from the Arduino IDE programming source code, first LCD row, this means 0, this means here is first 0 and 1. 0 row is the voltage. So 0 row is a voltage. This is a value for the voltage, and the second row is sensor value. Okay, this one the sensor value. This means on 7 volt, sensor value is 206 Fahrenheit. And when we drop the temperature to 80%, the sensor value is 164 Fahrenheit. Okay, when we push the push button here, it will reset because the push button connected to reset pin microcontroller. That's all for my video for lab 8. Okay, thank you very much, and assalamualaikum.